Hello and welcome. Today we want to handle the other method, which is called the cofactor method. The cofactor method can also be used to find the inverses. As the name states, you need to get the minus and the cofactors. So it's also a method of solving a 3 by 3 simultaneous linear equation with 3 unknowns. So we need to get minus and we also need to get cofactors. That's why it's called the cofactor method. So for you to get the minor, we have, let's say, M11, which this stands for rows and column. So this element M11 is in the first row, first column. If you move to the next, say M12, first row, second column, in that manner. So, and for you to get the minus and the cofactor, let's say M11. In our case, our M11 is A1. It will be equal to A1, and it's gotten by deleting the elements in the row and in the column of our A1. So when you delete the rows and the columns, you're going to be left with a 2 by 2 matrix, which is B2, C2, B3, C3. And now you can easily get the minor by getting the determinant of a 2 by 2 matrix, where you multiply the leading diagonal minus the other diagonal. We will have B2, C3 minus C2, B3. That's how we get a minor. And for you to get a cofactor, you will have -1 raised to power I plus j times the minor of 1, 1. Say here we are getting the cofactor of A11. And I represents the rows, j the column. So the position of that element, under what row does it fall? Under what column does it fall? So in our case, we will have 1 plus 1, which is 2. Now let's use a real example of a 3 by 3 matrix. And now to get the inverse, before we forget, A inverse is equals to 1 over determinant times the adjoint of A. And for you to get the adjoint consists of the matrix of cofactors, which has been transposed. Now let's see a real example on how we will get a determinant, on how to get an adjoint. So let's get straight into it. We have been given a matrix A is equals to 1, 4, 1, 3, -2, 4, we have 3, -5, 5, 6, 2. We want to get all the minors and all the cofactors. We have M11, and our M11 is here, 1. It's the 1. So we're going to delete the elements in the first row and in the first column. We'll be left with a 2 by 2 matrix, -5, 6, 5, 2. We're going to get the determinant, which will be -10 minus 30, which gives us -40. And our cofactor for C11 will be -1 raised to power 1 plus 1 times -40. This one is an even number, so our cofactor will still remain to be -40. We proceed to the second. We have M12, meaning it's in the first row. We have first row, second column, first row, second column. We are going to have M12. We delete elements in the first row, second column only. We are going to be left with 4, 6, 3, 2. We will have 8 minus 18, the determinant, which gives us minus 10. Cofactor C12 will be equals to negative 1 raised to power 1 plus 2 times negative 10. This value here is an odd number, so we'll have negative 1 times negative 10, which gives us a value of positive 10. And now we go straight to C13. M13, when we delete the first row, third column, we will be left with 4, negative 5, 4, negative 5, 3, 5, and that gives us 20 minus 15, which is equals to 35. Our cofactor C13 will be negative 1 raised to power 1 plus 3 times 35, which is equals to 35. Next we have second row, first column. We delete row 2 and column 1. That gives us 3, negative 2, 5, 2. We are going to have 6 minus 10, and this gives us 16. Our cofactor for C21 will be negative 1 raised to power 2 plus 1 times 16. It's an odd value, so we will have negative 1 times 16, which gives us negative 16. And continuing in the same manner, we will have M22. We have M22, which is equals to 1, negative 2, 3, 2. We are going to have 2 minus 6, which is 8. Our cofactor for C22 will be negative 1 raised to power 2 plus 2 times 8, which gives us 8. We move to M23, deleting row 2, column 3. We have 1, 3, 3, 5. When you get the determinant, it gives you 5 minus 9, which is negative 4. And our cofactor will be C negative 1, C23 will be negative 1 power 2 plus 3 times negative 4, which gives us a 4. We have M31, deleting row 3, column 1, it gives us 3, negative 2, negative 5, 6, and our determinant will be 18 minus 10, 18 minus 10, sorry, that gives us 8, and our 8 is positive, but we need to get our cofactor. We just continuing in the same process. We will have C31, which is negative 1 raised to power 3 plus 1 times 8 gives us 8. We are going to have M32, and our M32 gives us 1, negative 2, 4, 6. Sorry, this is negative 2. We are going to have 6 minus 8, which is 14. Our cofactor will be C32, which is negative 1 3 plus 2 times 14. It gives us negative 14. And lastly, we have m33, which is equal to 1, 3, 4, negative 5. We are going to have negative 5 minus 12, which is negative 17. But now you can see 3 plus 3 is 6, so our cofactor definitely will remain. It will not change. So you're going to have C33, which is negative 1 raised to power 3 plus 3 times negative 17, which is negative 17. And now we need the matrix of cofactors. We have matrix of cofactors. Before we get the adjoint, matrix of cofactors, we have matrix of cofactors, which will be, you're going to put all the cofactors together. We're going to have 40, negative 10, 35. We're going to have negative 16, 8, 4, 8, negative 14, negative 17. Now our adjoint is the transpose, which is 40, negative 10, 35. We have negative 16, 8, 4. We have 8, negative 14, negative 17. That's our adjoint. But now we need our determinant. Our determinant will be 40 times 3, or you can begin with 3 times cofactor of 3, which is 40, plus, no, our value here there was 1. We have 1 cofactor 40, 3, the cofactor is negative 10, plus negative 2, and the cofactor of negative 2 is 35. Cofactor of 2 is 35. That gives us 40 minus 30 minus 70, which means we have 40 minus 30 minus 70. We will have 110 minus 80. 110 minus 30, which gives our determinant to be 80. So our determinant is 80, and we have our adjoint, and our formula states that A inverse is equals to 1 over determinant into adjoint, which is 40, negative 10, 35, negative 16, 8, 4, 8, negative 14, negative 17. And that's our matrix. That's our matrix, or rather the inverse of our matrix A. Thank you for joining us. Please like, share, and subscribe. Thank you.